In this example, I'll cover conditional probability, the addition rule, and the classical definition of probability. So we have a survey of 400 people by gender and blood type. Let me explain the table first quickly. First of all, as you can see in the first column, the blood type, and the first row, the gender, male or female. Let me tell you what 75, for example, means here. It means there are 75 male who has a blood type O. Let's say what 140 means right here. 140 means that there are a total of 140 people who have blood type O. Those 140 is a mix of male and female. 400, what does it mean? It's the grand total of all people surveyed. So let me show you how to answer now the questions. The first question, what is the probability that a person selected has a blood type O? So we're selecting one person at random. We want to see what the probability that this person has a blood type O. The definition of probability is the number of favorable outcomes divided by the number of possible outcomes. We are choosing a person at random from the group of 400 people, so the bottom number should be 400. Now the top number in the numerator should be the favorable outcomes. We want a person who has a blood type O. It doesn't matter whether male or female. How many people have blood type O? We have 140, so your answer will be 140 divided by 400. You can simplify your answer if the question says so. Let me go to the next one. What is the probability that the person selected has blood type O given that the person is female? Now we're talking about conditional probability. So we want the probability, let's say person selected has a blood type O, let me call it event A. And given that the person is female, let me call it event B. So we want the probability of A given B. Okay, here's how we do this. The person selected at random. We want that person to have a blood type O given that the person is female. So the condition is we want the person to be a female. So we are selecting from the group of females. So what we put in the denominator is how many female we have in there. We have 187, so we put 187 in here. Now, we want the person to have a blood type O and female. Okay, how many people had blood type O and female? As you notice here, if I go there and here, they meet at 65, so it is 65. And that is the answer. Its probability of A given B is 65 over 187. Okay, let's go to C. What's the probability that the person selected is female given that she has a blood type O? Okay, selected is a female, that's the first event. Given that the person has a blood type O, that's event B. So we want the probability of A given B equals. What goes in the denominator? The condition is that we want the person to have blood type O. So we want to select it from the group of people who have blood type O. How many people in total have blood type O? We have 140. So we put 140 in the denominator. Now we want in the numerator, we want the person to be a female and a blood type O. How many female have blood type O? I just touched on that in the previous part. It is 65. So it's 65 over 140. As you notice, the probability of a person having blood type O given that the person is female is different from the probability of the person being a female given that the person has a blood type O. So probability of A given B is different from probability of B given A in general. Okay, let's move to the next question. What is the probability that the person selected is male given that he has blood type AB? Okay, so this is the first event. Let me call it E. And the person has a blood type AB. Let's call it F. So we want the probability of E given F equals. Okay, the condition is that the person has a blood type AB. How many people have blood type AB? We have 61, as if you look at the table. Okay, in the numerator, you should see how many people are male and have blood type AB. So if I go back to the table, male and blood type AB, I have 33. So the answer is 33 over 61. E. What is the probability that the person selected has a blood type A and the person is female? So and. This is not a conditional probability. He's not saying the word given here. So we want probability of type A and female equals. Number of possible outcomes, we have 400 people. We're selecting from 400. So we're back to 400 because there is no condition here. Now, number of favorable outcomes. Favorable outcomes means the outcomes that work in our favor. Our favor that to get someone who is type A and female. How many do we have here that have type A and female? Okay, you can go right here. And female, I have 47. So I put 47 in there. F. What's the probability that the person selected is male or the person has a blood type O? So probability. Okay, let me see here. Of male or type O. Okay. This is called the addition rule. You would have to do the probability of male first plus probability of type O minus probability minus probability of male and type O. That would be okay, let's write type here. Okay. Probability of male or type O. So if we get a male, we have success. If we get a type O, we have success. Okay, let's write the answer here. What is the probability of male? Probability of male, okay, we want to select a person. What's the probability the person selected is male? We have 213 males out of 400. So you put 213 out of 400 plus probability of type O. What's the probability that the person selected has type O? If I take you back to the table, type O, I have a total of 140 out of 400. Minus. Why do we subtract the probability of male and type O? Because some of the males could have type O and some of the type O could have been male. So we cannot repeat the same number of people twice. So that's why we have to subtract. Male and type O. Okay, let's see how many male have type O. We have 75, as you notice right here, guys. 75 male who have type O. So the minus 75 over 400. And the final answer will be 213 plus 140 will be 353 minus 75. So that will be 278 divided by 400. That concludes the question.